Okay, we're back with part 3 of inverse functions and logarithms, 0.5 AP Calculus AB video notes. And so the first thing I'm going to deal with is the change of base formula. So with the change of base formula, it's to take a logarithm of any base and be able to change it to another base. And very often we do this to have a convenient base, such as base e or base 10. So the way I remember the formula is that if I have the log base a of x, a is on the bottom and x is above it. So ln of x over ln of a, or log of x over log of a in the case of using a base 10. We very often use base e. It's just a very super convenient base. I think I tended towards that during my calculus years. So with that, we want to find the value of log base 7 of 350. And if you notice, I've already set it up where you have ln of 350 over ln of 7, or we could say that that's the same thing as saying log 350 over log 7. And then our final answer should still be 3.010 rounded to 3 digits. Now check this out with your calculator, but be careful that you close your argument in your logarithms each time, because sometimes you can make a mistake if you say ln of parenthesis 350 divided by ln of 7. Your argument for your numerator, it would be one expression, ln of the quantity 350 divided by ln of 7. So make sure you do that before, put the parentheses around the expression before you hit the divide key to make the quotient, okay? So that's the change of base formula. Okay, moving on, we want to draw the graph and determine the domain and range of the function. Now, I've kind of laid this out for you just for efficiency's sake, but I want you to look at a couple things. With respect to logarithms, we often say the logarithm is an exponent. And if you notice, I have a couple things highlighted here. In orange, you see that I have base 2 and then the y. The logarithm is an exponent. Get that in your thinking. And then the argument of the logarithm is x plus 1. So if I rewrite that, I can rewrite that in exponential form and say 2, the base, to the y power is equal to x plus 1. We'll be working on some warm-ups with that type of thing in class, just getting used to that. So then what I'm going to do, instead of having an input be y, I'm going to do an input of x instead, because it's convenient to do that. Now, the reason why we have the logarithm expression at all is because we like our functions to be solved for y. Okay, and let me just get my pen fixed up here, and boom. So now what I want to do is answer the question, what is x when y is -1, 0, 1, and 2? So you can see how I'm getting the points on the graph. So I've already got the math done. So if you look, I have the values inputted here. When y, these are the y values here. So when y is -1 through 2, and I get those different values, so that you see that when x is -1, the function value is -1/2. When x is 0, the function value is 0. When x is 1, the function value is the x value, so x is the function. When y is 1, then x is 1. When y is 2, then x is 3. And now I want you to consider for a second, what is the log? If I say x is -1, I have the log base 2 of -1 plus 1. And remember that you can't take the logarithm of 0. And that's going to turn out to be the logarithm of 0. So we don't have a value when x is -1. We don't have an associated value with y. So plotting those points on the graph, you see that we have that red curve. And that is the graph of y is equal to, let's put it in red. So that's y is equal to log of base 2 of x plus 1. And notice beneath it, I have the graph of y is equal to log base 2 of x. So this red graph is really just a translation 1 unit to the left of the parent function that you see right here, log base 2 of x. So graphing logarithms can sometimes be a little bit tedious, but made much easier when you translate it into an exponential form. Okay, so with that, underneath here, I'm going to scroll through very slowly and just say this, there were some probable questions on number 12 when you're working with it. You're back to an interest formula here, and you want to know what is the time when you invest $300, how much time will it take to make $600. That was question number 12, so if you're having trouble with that one. Then with number 10, there's a little manipulation on number 10. When you run into an equation like e to the x plus e to the negative x is equal to 9, there are sometimes these little mathematical tricks that we have. We know that we like quadratic forms. If I can make an e to the 2x, that's really e to the x squared. So in multiplying by both sides of this equation by e to the x, I get an e to the 2x, and I also have an e to the x. So if you look at it in quadratic form, as I've gotten down to this line, you can see that you have the quadratic form, and sometimes we'll say this kind of thing off to the side. U is equal to e to the x, and then solve that equation like so. So in this particular problem, since it doesn't factor this one, you're going to have to use a quadratic formula, and remember that's negative b plus or minus the square root of b squared minus 4ac to get your final answer. Now this may not be your question number 10, however, question 10, you can pause your video if you need to, and question 12, though they might not be exactly the same, they're just the numbers will be switched, okay? All right, so that's it for part 3 video of inverse functions and logarithms, and I'll see you on the next video or in class. 0.6, we'll be talking about trigonometry, so we'll have to get tricky with it. Na. Okay, thanks a lot. We'll see ya.